In this lecture, we're going to talk about what is continuous integration, why we need it, and different phases of adopting continuous integration. Jenkins is a continuous integration and build tool. We need to understand continuous integration before we start playing with Jenkins. Continuous integration is a development practice that requires developers to integrate code into a shared repository several times a day. Each check-in is then verified by an automated build, allowing teams to detect problems early. A continuous integration system usually involves a tool that keeps monitoring your version control system. Whenever a change to version control system is detected, the system would automatically build and test your application. If the build or test is not green, the system immediately notifies the developers to fix the issue right away. So why do we need continuous integration? One of the motivating forces behind CI is to detect problems or bugs as early as possible in the development lifecycle. Since the entire code base is integrated, built, and tested constantly, the potential bugs and errors are caught earlier in the lifecycle, which results in better quality software. Next, let's talk about different stages of adopting continuous integration. Introducing continuous integration into your organization is not something can be achieved in just one step. Usually, it takes you on a path that progresses through several distinct stages. Let's take a look at an approximate picture of each stage. Stage 1. There are no build servers at all for the team. The application is built manually on a developer's machine. The source code is stored in a central repository, but it's not enforced that developers need to commit their changes on a regular basis. What happens is that before release, a developer or a release manager would manually integrate the changes. During this stage, the code changes made by all developers were brought together and forged into a product. This sometimes involves integrating months of conflicting changes, which makes it very hard to anticipate the types of issues that would come up. Also, it takes a lot of effort to resolve those issues because lots of the code might be written months ago. Thus, this painful process can cause significant release delays. Stage 2. The team has a build server, and automated builds are scheduled on a regular basis, typically nightly basis. This build script would compile the application and runs a set of automated tests. Developers now commit their changes regularly, usually at the end of every day. If a developer commits conflict with another developer's work, the build server would alert the team members. Stage 3. The team is now starting to take continuous integration and automated testing to a further step. The build server is configured to start a build whenever new code is committed to the central repository. The build process usually involves compiling the application and runs a set of automated unit or integration tests. The build server alerts team members immediately if a build fails. Broken builds are usually treated as a high priority issue and is fixed quickly. Stage 4. Automated code quality and code coverage metrics are now run along with unit tests to continuously evaluate the code quality. Gradually, the CI process gathers useful information about our code base. We'll be able to answer questions such as, is the code coverage increasing? Do we have fewer and fewer build failures? This helps teams keep the quality bar of the code base high. We'll be notified if good testing practices are slipping. Stage 5. Confidence has been built up in the automated unit, integration, and acceptance tests, so that automated deployment techniques can be used to push out new changes directly into production. Next, let's talk about the difference between continuous integration, continuous delivery, and continuous deployment. There is a lot of confusion about these buzzwords. Continuous integration is the practice of merging development work with the main branch constantly so that the code is tested as often as possible to catch issues early. Continuous delivery is the continual delivery of code to an environment once the code is ready to ship. This could be staging or production. But the idea is the product is delivered to a user base for review and inspection, which can be QAs or customers. Unit tests during continuous integration cannot catch all the bugs in business logic, particularly design issues. This is why we need a QA or staging environment for testing. Continuous deployment is the deployment or release of code to production as soon as it's ready. Continuous deployment requires continuous integration and continuous delivery. Otherwise, the code quality won't be guaranteed in the release. So how can we implement continuous integration? There are different products and tools which can help you implement continuous integration in your organization. Some tools let you host the CI servers in your own network infrastructure, such as Jenkins. There are some other hosted CI products, such as Circle CI, which is completely hosted in the cloud. In this course, we'll be focusing on Jenkins Server. Continuous integration is also a mindset. When continuous integration is introduced into an organization, it dramatically changes the way how organizations think about the whole development process. Continuous integration is not only a toolset, but also a mindset. In order to get the most out of continuous integration, a team needs to adopt a CI mentality. Fixing broken builds should be treated as a high priority issue for all team members. The deployment process should be automated with no manual steps involved. All team members should focus on contributing to high-quality tests. Each of these requires improvements in the practices and engineering culture of continuous integration across the organization.